What I'm going to talk about today is essentially using short-lived credentials in combination with AWS, GitHub Actions, and Dagger in order to achieve one of those pillars of security that we talk about a lot, but is actually kind of hard to implement in practice, and that is making sure credentials in use in your system, especially credentials that belong to system identities, that's workloads, CI/CD pipelines, all that, only live for a short period of time and get rotated a lot. So I'm going to start with a motivationary example. About 40% of AWS identities are inactive. What we mean by this is that a lot of the individual line items that you see whenever you are looking at your users in AWS, be they actual developers, administrators, most of those actually are not in daily use. And that leads us to kind of the next problem, which is roughly a little under half of organizations on AWS in this the kind of combination survey case study that Microsoft published in 2023 have unrotated keys. And that is, these are keys that grant you permissions in your AWS account that have existed for 6 months or more without being rotated. So we care about this because a malicious user getting a hold of those credentials can use those credentials to do a whole bunch of things, data theft, exfiltration, installing exploits on machines, all sorts of nasty stuff. So as a DevOps engineer, which I was for several years, and then as a manager, this is something that I was worried about a lot. And using a combination of GitHub Actions and Dagger and AWS, I was actually able to build a system that meant that CI/CD pipelines in Dagger had access to a client AWS account for only a short period of time. I believe I configured it to 30 minutes by default. So in terms of the pieces that are involved here, this all starts out with a GitHub workflow, a GitHub Actions workflow. And it turns out that for every GitHub Actions workflow, for example, these ones, in the first step of the process, GitHub Actions actually creates a token. It's referred to colloquially as a GitHub token, unfortunately a loaded term. But every step of this pipeline has a token that gets generated that lives only for the duration of the pipeline. So that's all and well if you need to do something in GitHub Actions, but what about when you need permissions into your next system? So in my case, that is AWS. So we use a system from AWS called IAM Identity. And one of the things you can do with IAM Identity is use OpenID Connect, which is the standard for creating credentials. Here we actually exchange the GitHub token provided by GitHub. We send it to the AWS OIDC provider. AWS OIDC returns to us some temporary set of AWS keys. And that looks in AWS kind of like this. Inside AAM, you have identity providers, and one of those that I've configured in this client account is for OpenID Connect, specifically configured only to trust tokens that come from GitHub. And that's this provider right here. So the next step in your pipeline, in my pipeline in this case, is a straight up Dagger function that uses those AWS keys in order to do some action. In my case, it is deploying building a Docker container, pushing that Docker container to Elastic Container Registry in AWS, and then finally deploying it to a Kubernetes cluster that I set up. And all these are pretty standard Dagger pipelines. And the interesting part here is more to do with how the pipeline is actually called. So let me show you that workflow code too. We use a few kind of built-in actions and third-party actions in a GitHub workflow. The most important one is this one provided by AWS that configures AWS credentials for a particular role. In this case, it's this particular one for CI/CD. Later in the pipeline, you see that I'm using that same AWS action, and I'm actually passing the temporary access key, secret key, and an additional thing called a session token directly to Dagger. Dagger is using that internally with an AWS toolchain in order to actually do the things in AWS. So that's kind of steps 3 and 4. And then in the infrastructure in AWS, you do your deployment tasks, whatever that may be. In my case, it's deploying a Dagger container. And then after deployment, the AWS keys and the GitHub Actions token both expire. So that means that anybody who happens to get your keys, either because of a supply chain attack, a developer account that was not disabled a bit after they left the company, something like that, the tokens generated throughout this process are generally no longer useful after they expire. So in my case, I set the AWS keys to expire roughly 15 minutes after they are created. And the GitHub Actions token expires at the end of the workflow. In fact, you can kind of see it in this post checkout and complete job processes, where it's actually behind the scenes deleting all that information from the GitHub Action runners. So that's kind of the entirety of this demo. I built this project for a particular freelance client of mine, where I had a very simple pipeline that I wanted to automate as a part of my work with them, because we're making a lot of changes to production. It was needed to get this up and running very quickly. And when I deployed this work at the end of the day, I wanted to deploy it. I wanted to forget about it. And it was very handy both to have a Dagger pipeline in place to kind of be able to test locally and then have confidence it was going to work in GitHub Actions, and also for rapid iteration of these ideas. So for those of you who have worked in AWS before, you will hear my tale of woe and understand greatly. In my experience, the hardest thing about working in AWS is often the permissions framework. There are so many ways to configure permissions. Some of them overlap, some of them don't. And it can be kind of confusing to figure out where you need to make a change in order to get the permission system working. So I spent a lot of time on this particular bit of Terraform here that allows GitHub through the OIDC provider to assume the IAM role in AWS. And for the record, IAM role is basically the set of permissions for that user. I probably spent a couple of hours on these 10 lines of code trying to figure out what kind of assumed role policy I needed to add to get the OIDC provider working. So if you embark on this journey yourself, I highly recommend following both the tutorials that GitHub put up, the tutorials that AWS puts up, and also using something like this, where you have a AIM policy document data source, either in Terraform, Pulumi, whatever you are using, that makes it a lot easier to iterate on this particular part of the system. And I've included some resources that I used while coming up with this presentation and coming up with this pipeline, etc. And also the motivating example from the State of Cloud Permissions Risk Report from Microsoft last year. That's it for me.